Hello everyone. We're going to do another example on finding our sample standard deviation and variance using table data. Now, if you remember, this is actually interval data, but we often refer to it as table data because you can put it in terms of a table. So in this example, we have our class limits of 0 to 15, 15 to 30, 30 to 45, 45 to 60, 60 to 75, 75 to 90, 95 to 105, 105 to 20. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8 groups in this one, or 8 intervals. So this is going to be a little bit longer. We have frequencies of 71, 37, 13, 9, 10, 18, 28, and 14. So first things first, as always, we're going to figure out what our midpoint is for each of these intervals. So first one we have is 0 to 15. So if we were to add these two together, 0 plus 15, we get 15. We divide by 2. This is going to give us 7.5. So now this tells me again the pattern, because all of these have an interval of 15, which means this is going to be 15 plus 7.5, which is going to be 22.5. This one is going to be 37.5. This one is going to be 52.5. This one is going to be 67.5. This one is going to be 82.5. This one is going to be 97.5. And this one is going to be 100 and, oh, I messed up. 112.5. And now we're going to take each of those midpoints and we're going to multiply by its frequency. So the first one we have a midpoint is 7.5. We're going to multiply this by 71. So 7.5 times 71 gives us 532.5. Now we're going to take our midpoint of 22.5, multiply that by 37. It's going to give us 832.5. Now we're going to take our midpoint 37.5, multiply that by 13. 487.5. Now we're going to take our midpoint of 52.5 and multiply that by 9. This is going to give us 472.5. Now we're going to take our 67.5, multiply that by 10. That's going to give us 675. We're going to take our midpoint 82.5, multiply that by 18. 1,485. Now we're going to take our midpoint 97.5, multiply that by 28. 2,730. And last one, we're going to take our midpoint of 112.5 times 14, which is going to give us 1,575. So now what I'm going to do is I'm going to take the total of all of these. So I'm going to get 532.5 plus 832.5 plus 487.5 plus 472.5 plus 675 plus 1,485 plus 2,730 plus 1,575. We add all this up together, we get 8,790. So with this, we now have what we need to find our mean, right? Because we need our mean for the next step. So our mean x bar is going to be the sum of your midpoints times their frequency divided by the sum of the frequencies. So this is going to be 8,790 minus, or divided by 200. So 8,790 divided by 200, we get 43.95. So now that we have our mean, we can figure out this next value in our table by taking our x value, 7.5 minus 43.95. 22, 37, each of those, subtract that mean. So we get 7.5 minus 43.95. This is going to give us minus 36.45. Now I do the same thing for 22.5. I get negative 21.45. Next one, I do the same thing for 37.5. I get negative 6.45. Next one, I'm going to do the same thing for my 52.5. I get 8.55. Now I'm going to do the same thing for my midpoint, 67.5. And I'm going to get 23.55. Next one, I'm going to do the same thing for my 97.5. And I'm going to get 53.55. Oh, I forgot my 82.5. 82.5, so give me a second. That one was 38.55. And the last one, we're going to take our 112.5, and we are going to subtract 43.95, and we are going to get 68.55. So now we have how far each midpoint, which represents one data point, deviates from the mean. So we're going to take those because we have negative values, we have positive values, and of course if we took the weight into account, it would sum up to around 0. So we're going to square each of these terms. This allows us to only have positive or 0 values. So we're going to take each of those values and we're going to square it. So negative 36.45 squared is going to give us 1,328.6. Negative 21.45 squared is going to give us 460.10. Negative 6.45 squared is going to give us 41.60. $8.55 squared is going to give 73.10. By the way, the reason I'm putting zeros here, I am rounding these to 2 decimal places, so I'm just showing that it actually goes on beyond this, but it's rounding down to 0. That's the only reason why. So now we're going to take our 23.55. We're going to square that. Going to get 554.60. Next, we're going to take our 38.55. We're going to square that. We get 1,486.1. Now we're going to take our 53.55. We're going to square that. We're going to get 2,867.6. And then the last one, we're going to get 68.55 squared, which is going to give us 4,699.1. Okay, so now we have one more step on our table that we need to do, which is we need to take each of these values, and now we need to multiply it by that frequency associated with each interval. So the first one, we have 1,328.6, 1,328.6 times our frequency of 71. This is going to give me 94,330.6. Now I'm going to take my 0.1, and I'm going to multiply that by its frequency of 37. And I'm going to get 17,023.7. I got 41.6 times 13. This is going to be 540.8. I take my 73.10 times a frequency of 9. This is going to be 657.9. I'm going to take my 554.6, multiply that by 10. This is going to give me 5,546. I'm going to take my 1,486.1 and I'm going to multiply that by my frequency of 18. This is going to give me 26,749.8. I'm going to take my 2,867.6, multiply that by my frequency of 28. I'm going to get 80,292.8. And then last one, I'm going to take my 4,699.1 and multiply that by my frequency of 14, which is going to give me 65,787.4. So I'm going to take each of these values and I'm going to add them up together, and that's going to give me my sum of squares. So I have 94,330.6 plus 17,023.7 plus 540.8 plus 657.9 plus 5,546 plus 26,749.8 plus 80,292.8 plus 65,787.4. Sum all those up together and I get 290,929 on the dot. So that worked out nicely. Now, I have this value here, 290,929. So I can now use this to find my variance, and then from that, find my standard deviation. So my variance is going to be S squared is equal to the sum of my x values minus the mean squared times my frequency over the sum of my frequencies minus 1. And again, if you wanted to think about the fact that we have 200 data points, you could think of this as n minus 1, just like we had it before. So I'm going to take this top value, 290,929, and I'm going to divide by 200 minus 1. So I'm just going to write it in as 199. And this is going to be equal to 1,461.95. So this is going to be my variance for this data based on the intervals that I have and the frequencies that I have. So now I'm going to find my standard deviation. Now, of course, last time we just took the square root of this, but if you wanted to do it from scratch, let's say you didn't want to calculate your variance first, you can actually find your standard deviation directly by, again, taking the sum of x minus x bar, squaring it, multiplying it by your frequency, taking the sum of your frequencies minus 1, and then taking the square root of the whole thing. So from your table, this would be the same thing as saying that I need to take this value here, 290,929 divided by 199, and you take the square root of that, and you are going to get 38.24. And as we talked about before, you'll notice that this standard deviation makes much more sense within our data. We're saying that on average we deviate by 38.24. And this will make more sense in the next lesson when we talk about our empirical rule. But for now, just know that these are ways of representing how much our data varies. So when we had mean or median or mode, that told us where our data is actually located in space. Meaning that if we had a number line, that means that it tells us where the data is actually located. Let's say it's our mean mu. And then we're going to have some data around this point. And depending on how much it deviates, this is going to be defined by our standard deviation or variance. So this would be something like, if I had a normal distribution, is it deviating like this? Or is it really deviating? Or is it not deviating much at all? And it's almost all right around that value, something like this. And this is why together these two pieces of information are so important, because they tell us where is the data located in number space, right? If you have a real number line, where is it located? Where is the average weight of all the people that you measured? And how much does it vary? Is everybody very close to that center weight, or is it very spread out? And that means that it varies quite a bit. And this can actually have huge implications. One last example before we're done is this is actually something that led to a financial crash before the housing market crash in 2008. There was a company called Long-Term Capital Management. It had all these Nobel Prize winning economists and PhDs and all this kind of stuff, and they were a hedge fund making a ton of money for their clients. And they had this way of doing their calculations where they used Russian treasury bills, because US treasury bills were treated as basically a safe asset, and they treated these Russian treasury bills the same way. And it actually led to them making false assumptions, which made them lose a ton of money, and the whole market started to crash before the government stepped in. Now you might wonder why I'm telling you this story. Well, in finance, when you're going to learn more in chapter 5 about a normal distribution. But in finance, they have these things called martingales, which are called fat-tail distributions. And it's why some people will describe these events that are once-in-a-lifetime events or once every 100-year type events. And yet we seem to have them much more commonly than that. And it's because the data has a lot more fatter tails, which we'll talk about again. We'll talk more about the tails and all that stuff in chapter 5. But it means that those outcomes, those extreme outcomes that are on the ends, are more likely than a lot of people predict. And this is why things like where your data is located is super important, but also how much does your data vary? It tells you so much that those two values can explain so much about data, which is why they're so important. So that's it for this lesson. In the next one, we will be covering the empirical rule and Chebyshev's inequality. Thank you for watching. To continue learning, click the linked video here for the next lesson. If there's a topic you'd like me to cover, let me know in the comments. Don't forget to subscribe, and I'll see you in the next video.